Now we will talk about our I/O read timing diagram. Now, what is the difference between memory read and I/O read? Is that in case of memory read, the address provided is a memory address. In case of I/O read, the address provided is an I/O address. Number one difference. Number two difference is that memory addresses are 16-bit addresses, while I/O addresses are just what? 8-bit addresses. 8-bit addresses. Okay. And finally, the third difference is that I/O read operation may take much longer compared with, although only two T states have been shown over here. Okay, only two states have been shown over here. It depends upon the type of I/O device. Some I/O devices might be very slow to send data, while some I/O device might be fast enough. So depending upon the nature of I/O devices, okay, the I/O read operation can take longer than 3T states. Okay, that's something else. So these are the three differences between memory read and I/O read. Memory read and I/O read. Okay, first of all, we will export this to our whiteboard, and okay, now the first event, address appears. This is the first event, address appears. Although the address is just 8-bit, see, the address is just 8-bit. What happens is that the entire 16-bit must be used. Okay, in the lower value, AD0 till AD7, okay, the address 80 will be, well, in the higher byte, so address will be basically not 80H, it will be 0080H. 0080H. So the upper byte will be 00H and the lower byte will be 80H. Not the opposite, please be careful. Don't write 8000. Okay, it will be 0080. The address is only 8 bytes. Okay, however, we must send 00 to our address bus. Okay, so it is 80H. The address is coming to AD0 till 87. Actually, I can make this line smaller. Okay, I can make this line smaller. Okay, so you should understand that the actual address is just in AD0 till AD7. This is 80H. Okay, and because an address is being issued, it is not data, it is address. So hence ALE is 1. ALE is 1. And about IO/M, this is the most important one that you should remember, that it is 1. That is the main difference. It is 1. The address is IO address. It is just an 8-bit address, and the IO/M is equal to 1 in case of IO read or IO write. Okay, that is the third difference. And the fourth difference is that the length of the read operation can be longer than 3T states depending upon the nature of the IO device, whether it is fast, whether it is slow. Okay, it is not as fast as memory. Okay, so this is event number 1. This is event number 1. Okay, address, or I will better write this as IO address appears in address bus. This is your event number 1. Okay. Now the second event. Okay. After this event, what happens is that now the address has been selected. The IO device which is supposed to be read is also now selected, just like before. The address remains left on the bus, and so on. And once this is complete, in the next T state, and the read command is issued, just like before. Just like before. The read command is issued just like before, and this is where it happens. This is the second event. Okay, this is the second event. Read command is issued, and from here what happens? Data starts flowing in from the IO device towards the microprocessor, towards the accumulator of the microprocessor. Please be clear. Understand that data starts flowing in from the IO device to the accumulator of the microprocessor. Event number 2 is data read start from IO device. This is event number 2. Take our IO certain time lecture. Okay, certain time lecture. It has been shown over here that it takes 2 states. It can take more as well. Okay, but we will assume for convenience that it takes 2 time states. So here what will happen is that this is end of read from IO device. This is end of read from IO device. Please note once again that the read signal is the same read signal. Okay, the only difference is IO/memory. The only difference is IO/memory, which is equal to 1. Okay. Read complete. Okay, so this is our event number 3 from our IO read timing diagram. Okay, you should understand the difference between memory read and IO read. Okay, you should understand that very neatly, that IO/M is equal to 1. The addresses are only 8-bit address in case of IO devices. And finally, what else is that the read operation takes longer. The read operation takes longer because the memory is faster than, okay, memory read is faster than IO read. Over here, 2 T states have been shown. Okay, it might be more than that. Okay. Now we come to IO write timing diagram. What is the difference? No difference. Same as that before. IO read जस्तै यहाँ पनि त्यसरी नै एड्रेस आउँछ र second T state ma the command that is issued by the microprocessor, or the signal that is generated by the microprocessor, is a write signal. It is also an active low signal. It is also an active, as we have seen previously, write is always an active low signal. So once the write signal is issued, generated, data starts flowing out from the microprocessor through the data bus to the IO device. Okay, write operation to IO device may take much longer than IO reading. Okay, because for example, there might be very slow devices which are reading this, which are going to read this data. Okay, IO/M is equal to 1 because the address is basically an IO address. Okay, बुझे ये सब कुरा? Okay, so this is out of the topic. We are not going to study this. Okay.